My name is Alejandro Schnakofsky. I'm the Chief Tech Officer of Prevalon Energy. Continuous improvement of fire safety is critical for battery energy storage systems and for the acceptance and growth of the industry. System integrators have a duty to continuously innovate in this area and implement the latest best practices to avoid and mitigate catastrophic failures. Due to the nature of lithium-ion batteries, the only feasible fire protection strategy is to focus on mitigating heat transfer and the propagation of thermal runaway. Containment is the priority, but we must also plan for the worst. This has led the industry to develop large-scale fire test protocols aimed to characterize what would happen in the event of a catastrophic failure. Would a full enclosure in thermal runaway be contained within it or propagate to adjacent equipment? I'm at a large-scale fire test lab where we will be burning a full HD5 enclosure. This will enable us to capture invaluable data to improve our design and rationalize equipment setback distances and site layout so we can avoid propagation of a catastrophic thermal runaway event. The test consists of 4 HD5 units, an initiating unit that will be driven into full thermal runaway by heating cells within it, and 3 target units that are representative of an actual site layout. The test will look at the heat transfer from the initiating unit to the target unit. The objective is to ensure that the enclosures are properly designed and built, such that the heat released by the initiating unit does not result in thermal runaway propagation to the target units. Prior to this large-scale fire test, we have conducted 9548 tests to characterize cell, module, and unit thermal runaway, and to ensure no module-to-module propagation occurs in the event of a cell thermal runaway failure. To initiate the large-scale fire test, we will be forcing several cells into thermal runaway, overwhelming heat transfer mitigating features to ensure propagation and a full burn of the entire enclosure. There are hundreds of temperature sensors installed in the 4 units so the dynamics of the event can be properly captured. There are also heat flux sensors strategically placed throughout the test environment. Emissions are also captured and analyzed via a hood placed on top of the target unit. All this data will be leveraged to optimize the layout of the equipment on site, improve our enclosure design, and inform our emergency response procedures.